Guess we'll get started. My name is Wes Caldwell, and I work for ISS, Intelligent Software Solutions, as you see. And today I'm going to talk about a customer that we're working with to build an application that essentially I call shrinking the haystack with Solr and NLP technologies. And I'm really going to focus on the use case, the business use case of it, and then dive into some of the technology that we're using to solve our customers' problems. So just some of the topics we're going to cover today. Just an introduction to the company and our customer base and who we serve. Some of the data challenges our customers are facing. How we've built a data processing pipeline to solve those customers' needs, and how Solr and natural language processing technology fits in. Our document processing ecosystem, kind of go over all the open source components we're compiling and putting into this pipeline to help our customers. And then some additional Solr features that we use, specific Solr features like synonyms and et cetera, that kind of help us build this document processing pipeline. And then some of the NLP techniques we use. We use two distinct NLP techniques, and I'll go over and compare and contrast those techniques. And then really why we use multiple techniques and how they complement each other. And then I have a quick demo of the app. Little disclaimer, it's across the pond in one of our DMZ servers, so it might be slow, but we'll see. We'll give it a shot. Okay, so a little bit about ISS, the company. We are a software company, and we're headquartered out of Colorado Springs, Colorado. And our primary customers are federal and local law enforcement. So we do a lot of work with Department of Homeland Security, a lot of military customers, Central Command, a lot of intelligence agencies in the DC Beltway area. So we do a lot of work with a lot of federal agencies, a lot of federal local law enforcement. Simply put, we build software that helps analysts find the bad guys. So we're enabling analysts in a lot of different problem domains to solve some tough problems on culling through a lot of their data and trying to whittle or shrink that haystack down to a manageable size so they can actually do analysis and try to root out and find bad elements, essentially. Just a funny story, we have a lot of engineers actually embedded with our customers. And one of our customers is in Afghanistan. So we have about over 50 engineers in Afghanistan today supporting our troops, the NATO forces in Afghanistan. And so you can kind of guess the interview process here when we interview a potential engineer, and we're like, hey, Java, Bootstrap, Hadoop. Oh, can you go spend Christmas in Afghanistan as well? And the reaction is, just that look on their face is kind of, priceless. So, but anyway, just a factoid about the company. So let's talk a little bit about the data challenges. Will Hayes had mentioned this in his opening talk. Data is growing at exponential rates, obviously, and this is not foreign to our customer set as well. Most of the information that we get these days is not structured. Used to be, we built analysis tools in the past that would mine large relational databases, map in those databases, very structured, table-driven type data sets. What we're seeing more and more is obviously a plethora of unstructured data sets. This little factoid, I know you probably can't see the CSC infographic on the right there, but just talks about the explosion of unstructured data in the world that we live in now. And the fact that by 2020 we'll have approximately 35 zettabytes, 35 billion terabytes of information in digital form. So that's just representative of a large data problem. And again, this holds true to our customers as well as, I'm assuming, your customers as well. And obviously the unstructured part of that data, it's easy for humans to read a document and say, oh yeah, I understand the actors and what's happening in this document. It's not as easy for a machine to do the same thing. And that's where NLP technology comes in. It's not perfect, but it's a tool to help in that amongst that goal. So our customer's data environment. All right, so since we have a lot of federal and military-based customers, we have a lot of different data sources, literally thousands of data sources and feeds that we are trying to pull in and manage for our customers. Media. I mean, it's not a shock that if the FBI goes in and kicks a door in and arrests a drug smuggler, that they're going to find documents and a variety of things in that area, and they're going to want to exploit that information. Human interactions. Our current operations in Afghanistan, there's a lot of patrols. There's a lot of people talking to other people. These human interactions, they get collected and put into databases. That's obviously, again, not a shock to anybody. Geospatial information. Tons of geospatial information, and this, again, not a shock. For example, the picture of the predator down there in the bottom left. That is a flying sensor. It flies around and it collects information. And it also emits its location every couple seconds, every second. So there's a lot of geospatial information from all the tracks of aircraft flying to just all the sensors that are in the area collecting information. All that's coming into an environment where analysts want to kind of cull through and say, okay, what's important and what's not important? What's noise and what's signal? A lot of imagery and video, a lot of open source sources as well. So news sites, RSS feeds, Twitter, Facebook, all these types of social media, RSS and news sites are all brought into an environment. And the intent of that is to kind of correlate. You're trying to correlate all that information into time and space. So temporal and geospatial correlation to try to understand essentially give me a picture of what's going on in this area, what's happening, what's the local conditions, et cetera, et cetera. So our customers' data environment is very large, very similar to other customers' data sets, just in a different way. So this is basically how our analysts feel. They're sitting on a mountain of information, a huge haystack of information, and they're trying to find the pieces of that haystack that help them do their job for their particular analysis task. So trying to make sense of all this information, really trying to whittle it down to a manageable size. So that's really the intent of these tools that we're building for them, is to whittle it down. Not to give them that needle in the haystack, but really to whittle that information down. So their need, they're looking to extract information from these massive data sets and provide what they call actionable intelligence. So this is really just, I need an understanding of the situation. I need to be able to act on that information. So if it's tracking, drug operations across the border between the U.S. and Mexico, if it's looking for local gang violence in a local city, it's actionable information. That's what the analyst needs, and that's what they want. And search and NLP technologies are key enablers to that. They allow the analyst to reliably search for information they know, and obviously, using NLP techniques, they can also discover information that they don't know about. And so search and NLP kind of play hand in hand. They're kind of hand in hand in helping the analyst kind of get to that area. And it's critical, especially in tactical environments, and I'll talk a little bit about that in a minute. It's critical that we provide the tools that allow them to kind of shrink that haystack. More digestible size allows them to seed that into other analytic efforts, other analytic processes, and they can target it at a particular domain. So they want to be able to tune the search system and the NLP engine for a particular domain, for vernacular and words that are used in their environment. Counter-narcotics, counter-terrorism are just a few examples. And it's very important. So in a tactical environment, you don't have the luxury of a data center. You don't have the luxury of large bandwidth. You're not on the general internet. So kind of getting that information culled down to a sizable amount that can actually move through a low-comm, high-latency environment is critical to get that information to the analysts. And the time to live of that data is very critical as well. I mean, typically, information collected in certain tactical environments lives for about 24 hours, and it's really not worth anything after that. So you're really trying to deliver that information, time critical, to the analyst to allow them to do what they do best, which is look through the information to determine what's going on. So again, like I said before, it's not about finding the needle in the haystack per se. It's about giving the tools to the analyst to allow them to kind of cull that information down and then make a human decision, understanding what's going on. The human in the loop is critical. You're never going to replace, in my opinion, you're never going to replace that human element, the human that can interpret the information and make a decision. But you can definitely give them tools to help them, enable them to make better decisions, because they're not culling through 2 million documents. They're culling through maybe 100,000 documents or 100 documents. So where did this journey lead us? Well, we basically came up with a data pipelining technology using a lot of open source technology. So we're basically pipelining information and documents through a processing system that allows and gives the analyst a UI, a user experience that actually allows them to search through that environment and get to the critical information. So here's our basic approach. We started with, well, actually, I'll go back to that. Our basic approach was we did nothing. It's empty. So our basic approach is, first we have to acquire the content. So we have a content acquisition system that pulls in structured, unstructured, and semi-structured information. Okay, so it pulls that into a content cache, what we call a content cache or a haystack. And some of the characteristics of this component of the system, you have to have, obviously, connection to the data sources. So there's a connector architecture there. And we've used standard sort of enterprise integration processes, Spring integration, some ESB technology, as well as other ecosystems like Hadoop with Flume, Kafka, things like that, streaming APIs as well. So we've used a combination of techniques, traditional techniques, relational database mappings pulled in, as well as newer big data type techniques as well. And then there's some level of data normalization. And when I say data normalization, it's not at the level of I'm going to put this into a structured XML schema that's very rigid. This is more normalization at a more metadata generic level. So you're looking at giving it enough structure so you can kind of understand where it came from, the origin of the data, et cetera, but not trying to lock it into a schema in a traditional relational sense. So then there's obviously, in our world, the data compartmentalization. So we have a lot of organizations that want to compartment different types of data based on sensitivity to that data, security around that data. So we have to have an architecture that's flexible enough that as data is coming in, that we can put it in different buckets and sort of lock down certain areas of that data. So that's key, area number one. The second area is now we need to enable search and discovery of that information. So that information is put into a Solr index. Go figure, right? We're at a Solr Lucene conference. So we put it into a Solr index. And, again, some of the characteristics of that are you're optimizing that index for search, hence why you put it into a search index. We actually have written an environment around the search capability that allows analysts to kind of bin, save queries, which we call topics. Essentially, they're topics of interest or case files that they can kind of take search results and say, okay, I want to put this into a bucket, and I'll call that, my favorite stuff or something like that. And obviously, you get the standard advanced features of like faceting, autocomplete, all the standard stuff that Solr provides. And then we also provide a synonym, what we call a semantic search capability, which are based on, and I'll talk a little bit about this later, on these pluggable taxonomies that the customer can give to us to say, these are the kind of things that in my world, this is how I see, it's almost like a bag of words that actually is sort of synonyms that they use in their environment. We can load those in, which gives them a more friendly user experience when they're searching for information in their terms, not just in strictly search, Solr syntax, for example. So if we stopped here and you look at this system, this is a pretty standard, this is probably not shocking again, but it's a pretty standard search system. You acquire content, you put it into a search index, and you provide a UI on top to provide the analyst or users the ability to get to that information. So the thing that we start adding in now, there's two other components to this. We add in what we call semantic enrichment. So this is where the NLP technology enters into the equation. So what this does is, obviously you're doing things like entity recognition, entity resolution, continually feeding back into that index, categorization of entities, people, place, things, other types of categories. And it's really based on two fundamental approaches that I'll go into in further slides. But basically, our customers have lexicons that define their domain, their problem domain. And these lexicons are essentially taxonomies of information and how things are structured. So in a simple sense, you could think of it, a simple taxonomy is, in the financial industry, there could be a taxonomy, or in the loan industry or mortgage industry. You could define taxonomies of common words that are used, and you could load that into the system and allow those categories to be extracted. And I'll go into detail in a little bit on that. The last piece is what we call data perspectives. So this is really in the grain of polyglot persistence. So you have your data in an environment, you've got it staged into a cache, you've got it searchable in a search index, but you might also want to siphon off portions of your data and actually put them into optimized forms. You might have a graph representation in Neo4j for some of your information that has a lot of linkages between data. And you might want to put a UI on top of that to browse those relationships and go through and actually understand these relationships between your data. But that might just be a subset of your data. It doesn't have to be all your data. So these data perspectives are really reduced, essentially using MapReduce and other techniques. You can reduce those into these various data stores. There's time series databases. There's geospatially centered databases that you can put optimized information in. So essentially, the point there is about the polyglot persistence. It's about putting data into the form for the types of questions you're asking that data. So if you're asking a lot of geospatial information, you more than likely will put it into a geospatially optimized form so you can do geospatial queries. So this data perspectives is kind of a complementary sidecar, I guess, to the whole system. So just kind of a window into the document processing pipeline that we use and all the various open source technologies that we interface with. So as a document's going through this pipeline, you're obviously acquiring that document from somewhere, and there's some level of content management that has to occur there. That content management, we've used two basic approaches. Apache Jackrabbit is a JCR compliant Java content repository API. Very simple to use, simple API, put things in, get things out, version things, etc. Hadoop HDFS is another option, a distributed file system for large amounts of documents that actually can feed the rest of your pipeline. So we've used those two kind of approaches, depending on the data size, depending on the customer's requirements. When you get into the text extraction, we're using things like Apache Tika, Boilerpipe, which is a web scraper essentially that turns HTML into semi-structured text. When you get into the named entity recognition piece, now you start getting into the NLP technology, which we use three fundamental pieces there: WEMA, which I'll go into more detail later, OpenNLP, and Gate. Those are the three sort of NLP technologies that we use. We also try to extract geospatial information from text. And that's what we call that geospatial tagging or geospatial extraction. And GeoNames is an open source entity resolution, I guess, if you will, database that will resolve things like city names to locations on the earth, latitude, longitude, etc. So we employ techniques to use GeoNames, and we actually do a specific feature there where we put a GeoNames database into a Solr core, and I'll go, like I said, and I'll go into detail in a few minutes on that. So when you get into the clustering and classification area, you're still using the NLP technology there to do the clustering and classification. So that's the WEMA, the OpenNLP, and the Gate. And then when you get down to the indexing side, obviously Apache Solr is our choice for that. But this is just kind of a window into this document processing pipeline ecosystem that we employ. Kind of a grab bag of open source components, I know, but it actually has worked out pretty well from the application side. So, okay, so let's talk about some of the Solr features that we actually find useful that actually help our customers kind of whittle that haystack. The synonym feature, and again, if you're a frequent user of Solr, the synonym feature is nothing new, but it's a very powerful feature for us. So we load hierarchical synonym sets that are driven by our customers' domains. So they will define essentially taxonomies of how things are related in their world, and we can load that into synonyms which help us and help them when they do searches. So for example, if this was a weapons-driven sort of domain, you might envision a taxonomy that says there's these types of weapons, and one of the types of weapons is an AK-47, an M16, yada, yada, yada. So when you load those synonyms in, as documents are getting indexed, the user doesn't have to search for, well, show me all documents that have AK-47s. They can go more abstract and say, show me all documents that contain weapon-type information. Boom, you get the hit on the document that has the AK-47, the M16, et cetera, et cetera. So it seems like a very simple use case, but it's very, very powerful for our customers. Very powerful. It's really what I call practical analytics. So it's a real simple use case, but it has proven to be very, very useful. Another thing we do is geospatial resolution, and we talked about the GeoNames database. It's used by the NLP pipeline. So in a document, if you have a reference to, for example, Paris, say it just says Paris, it doesn't say Paris, France, or Texas, or whatever, and you want to resolve that to a latitude and longitude, a point on the Earth. What we've done is we've taken the GeoNames data set and loaded it into a separate Solr core, and then we use that core for quick lookups on that geospatial entity resolution. So it's very powerful because it allows us to, obviously, for quick lookups, you resolve Paris to a latitude, longitude. Well, you would ask, well, how is that different from, Paris, France versus Paris, Texas? Obviously, boosting can be applied, so you can start applying Solr concepts and rules within the Solr engine to allow you to kind of resolve the entity based on your needs. So in the case of a boost parameter, you could use population. That's a pretty simple, straightforward boost parameter. So in that sense, if you had a document that just said, Wes went to Paris, it would resolve to Paris, France because of the population boost. But obviously, we can override that very, very easily in Solr. It allows us for local conditions. So if we have a analyst cell in Afghanistan, and they're like, we know all the information coming into this system is mainly in the Middle Eastern area. It's mainly in Afghanistan. So let's boost, when you start resolving geolocations, let's make sure they live within a 200-mile radius of Kabul, for example. So you can start putting these rules, these custom rule sets in place, which really make it powerful because now you can tune essentially the geospatial resolution for your customer set. Very powerful feature. We use it quite a bit. So we use basically two fundamental natural language processing techniques as well. WEMA, which is an Apache project, it is the pipelining technology that we use to enable the GATE and OpenNLP machine learning engines, natural language processing engines. So basically, it has an abstraction called an analysis engine, and that encapsulates a series of steps in this pipeline that we can plug in GATE, a gazetteer-based approach, and also the OpenNLP learning approach technique. So it kind of abstracts to us the details of those engines, which is actually very powerful. So if a new engine comes out or a new particular piece of that pipeline comes out that's more optimized for what we're trying to do, we can unplug that particular piece. Say it's a new lematizer or a new stemmer. We can plug that in independent of the fact that it's OpenNLP or GATE. So it's actually very powerful for us. And we're actually starting to look at WEMA AS, which is the asynchronous module for scaling out. So obviously, as the more documents come in, the more we have to scale out. There's different approaches there. We could use things like MapReduce, or we could look at WEMA AS, which is an asynchronous module for the WEMA system. And like I said before, it abstracts that vendor-specific NLP engine details, so you can kind of plug and play different implementations, which is very, very powerful. So the two fundamental approaches we use for NLP is the first one is called GATE, the General Architecture for Text Engineering. It's out of the University of Sheffield in the UK. It's essentially, we use the gazetteer-based approach, which essentially a gazetteer is a dictionary of words, basically. And what you're trying to do is you're trying to extract, as documents come in, you're looking for key terms, phrases, etc., that live in this dictionary, and you're categorizing your documents in certain ways. So, and you can define n number of categories that are generic, as well as customers can define. So the power of this is that it's a real practical analytic from a customer's perspective. So they understand. So most analysts understand what the current conditions are. They understand what they're looking for. So for example, if the FBI had the top 10 most wanted suspects in the world, and they always have this list, obviously, and they're looking for those names across airplane manifests, for example, who's buying tickets, who's flying on planes. It's easy to put that into a gazetteer and say, you know what, when all these documents come in, I want to know if Wes Caldwell comes up. Every time, I want to know it. So you don't have to do advanced NLP in the sense of, I just know that I want to see Wes Caldwell. So the gazetteer-based approach is very precise, can get you what you want when you want it. That helps the analysts out a lot because they know exactly what they're looking for in certain cases. The other approach is the supervised machine learning approach, the OpenNLP approach. So the beauty of that is it's context aware. So you're training a model with a corpus of information. Requires data scientists and SMEs to understand what information you would want to tune that model with. And it's obviously based on probabilistic theory. Maximum entropy is the default in OpenNLP. But basically, the power of that is you're training it to be context aware. So if there's a sentence structure that says Wes went to Paris, and then you swap out Wes for Frank, it's going to know that Frank went to Paris as well, whereas the gazetteer-based approach is just looking for Wes. It's looking for literal dictionary-based type approach. So why would we care? Like, why would we use both techniques? So both approaches have pros and cons, obviously. The gazetteer-based approach, it's very precise. You get what you're looking for. So if you know what's important to you as an analyst, you're looking for certain names, places, events that occur in certain areas, you're getting those results immediately out of your documents. And it also allows the analyst to tune it. So if you had, you can envision a system, a database that would contain these keywords. An analyst could have a UI to go in and add the key values that they want to look for. Very simple, very straightforward, and it works. But the cons are you're only as good as that gazetteer. You're only as good as what you load into it. It's not going to learn over time different contexts. So that's one of the detriments to the gazetteer-based approach. In the supervised machine learning approach, once you properly train that model, it's very good at context. It's very good at extracting relationships between subject and nouns and predicates and verbs, and understands the structure of language, and it helps you understand and extract new things that you might not know about. But one of the detriments is it requires a data scientist or a SME to kind of produce those quality models. And there's multiple models. It's based on the type of data. You can't necessarily pull in just a generic set of, hey, I'm going to pull in a tactical data link, open source intelligence, Twitter feeds, and then somehow have one model understand all of that. You have to tune it for the particular type of information that you're pulling in. So again, it's tedious, but if you have the diligence and the staff, you can make this really work very well. And this graphic off to the side, I know it's hard to see. Basically, this is just showing sort of a supervised machine learning process. You basically start with a data set. You build what we call a gold standard, and you feed that through, and you train the system over time. You have to pre-annotate all the information going in. You're essentially saying, here's the answers to the test. Now produce a model that can model that. And then you go through and you keep introducing new information over time. And again, it's as good as the information you feed it. So if you have 100 records versus 1 million, it's going to be less accurate, I guess, over time. So this process can be tedious, but it actually does provide a lot of value. And if you have the right data set and the right approach and the right discipline, you can make this work very well. But bottom line is, both approaches work well, and both approaches together kind of give you the best of both worlds, right? So a combined approach helps you find the things that are relevant, but also helps you find those within those contexts things that you don't know that exist but are relevant, that you would determine would be relevant. So it really gives you kind of the best approach of both worlds overall. So just some additional information just on the various open source projects that I listed there. It's just informational. I'll fire up the app real quick. Let me get out of this. Just show you kind of manifestation of all the slideology there that we had. Scale, but here's the basic app. that we've built for that particular customer. As you can see, this is just sort of a rolling record of what's been ingested into the system. You can see that there are some duplicates because multiple sources will post multiple. You've got the various faceting information here. Some basic stuff on content ingestion is you've got the source, the content type, and so you can filter based on, basically content type. And then obviously for various articles here, this is the Al Jazeera feed, again open source RSS feed. You can just browse the articles, and this is obviously a representative data set. So there's basic information here. So then you can drill down with keyword searches, et cetera, standard search application functionality that everybody's used to. Does your basic highlighting. But if you drill into one of these documents or one of these articles, you'll see that here's the entity highlighting view, if you will. And there's categorizations over here for, all the oranges are dates, all the blues are locations. So these are all results of the NLP process that has culled through this information and actually tagged it with the various entities that it found. And then you can drill down to, the source information itself, which in this case is the Al Jazeera website. And there it is. There's the article that we pulled in via boiler pipe in this case. Basic features. I mean, I just wanted to kind of show some basic features of the app. The categorization engine, again, using the NLP technology, so you can kind of see here that we've got facets driven off of categories that the NLP engine came up with. For example, people, so this is the most occurring people. These are the counts. It's probably hard to read over there, but you've got categorization of people, organizations, locations, and obviously you can click on these and filter the result set based on those. Then you can kind of get specialized. You can kind of, based on customer, requirements, you can focus on. I'm looking for, in all these documents, these open source feeds, I'm looking for things like, are there any mention of weapons? Are there mention of chemical-based weapons? Are there mention of biological-based weapons? So again, with the dictionary-based approach, you can put in those key terms that allows the categorization to occur, thus giving you a facet on the left-hand side here for the customer that's kind of tuned for their particular domain. Or if you're local law enforcement, you could put the various gang affiliations in that column. It's whatever you want to drive. So it's basically a pluggable mechanism to allow the users to sort of add those categories on the fly and build those dictionaries. So. Go back. So that's really all I have. Anybody have any questions? Okay.
I think you mentioned that you're extracting relationships between entities, possibly as well as entities.
Right. Right.
How does that work?
Yeah. I mean, it's an art and a science together, right? Obviously, NLP techniques can kind of extract. John talked to Bob, and you can kind of draw inferences there that these are potentially related. But at the end of the day, and we surface those in a Neo4j database that kind of show those relationships. At the end of the day, I don't know what percentage, maybe it's 70% are really just bogus relationships. There's some kind of, loosely defined tie. The more interesting ones are when you're extracting text about essentially structures of, say it's a gang, and you're trying to understand the hierarchy of a gang, who reports to who. Those are more interesting questions to ask and a lot more difficult to extract. So we really want to have a system that combines analyst input, like their local knowledge of the situation. For example, a police officer would understand the organization, who's the gang leader, because they drive around and patrol that area all the time. So you want them to be able to enter that information and then also be bringing in other sources of information that might either correlate that or collate that information together. So, but it is an art. I mean, it's not a solved thing. Any other questions?
One of the problems with NLP approaches is that you do get a lot of noise. have you taken any additional measures to post-filter the stuff that you get out from the classification to validate that it's actually good?
Yeah, I mean, you acknowledge the problem. It is. You get a lot of noise, and you're trying to find that signal, and it's a trade-off. I mean, a lot of times you don't want to extract information from the analyst, let them kind of cull through it. But at the same time, you can't give them, a billion documents and say, hey, make sure, pick out the 100. So it's definitely a challenge, and we haven't solved it per se, but it is something that they're asking for. Like, how can we try to filter out as much noise? A lot of that can be defined by, some of the techniques I described in the brief with just their taxonomies, their hierarchies of information to try to give them the information in the way that they see it and try to filter out some of that noise, but it's still a challenge for sure. Yes?
So how do you have any tooling around checking the quality of your training data for your machine learning? And also, how do you maintain the quality of your machine learned models over time, when you need to?
Right. Very good question. Yeah, I mean, and as I acknowledged in the presentation, it's difficult, it's tedious to train and keep those models up to date. And as the information is changing and the situations in the world are changing, you have to constantly be on top of it. So we have dedicated subject matter experts that work on this and try to keep abreast to the latest information and try to train those models. Testing the quality, essentially, the quality of the F measure, if you will, of that model can be difficult because you have to have that gold standard that says, okay, this is the state of the world, and let me run it through. So there are some techniques in OpenNLP that you can run validation through with a data set, and it can kind of give you the F measure, but it's an art and a science. I mean, I know I keep saying that, but it is. It's really in that gray area. So we try the best we can with our subject matter experts.
Can you give us an idea of the amount of documents you can treat per day, per hour, per minute?
Right. I mean, this system is rolling out into our customer's environment, and there's literally, I would say at this point, the scale that we brought in is in the millions of documents, and moving into the tens of millions of documents. It's not in the, I wouldn't even categorize it as big data yet, because we're not talking hundreds of millions and billions, but it can easily get to that point by the more data sources we add. So if we start throwing in, geospatial tactical data links, for example, like every report of every track flying around the world, that obviously can become large. There's small messages, but there's a lot of information. It's typically what we see. You see small messages and a ton of it, or you'll see big documents and less of it, I guess is the way to characterize that. So. Any more questions? All right. Thank you for your time. Thanks a lot.